welcome back to DevOps. As a quick bit of housekeeping and a reminder, we are planning lightning talks this afternoon, specifically for DevOps, separate from the main conference lightning talks. If you would like to submit to that, if you go to the program on the website and you scroll down a bit, there's a link to Google Forms. That'll be closing partway through lunch, and we'll be picking talks then. Up now, though, we have Luke. Luke is a senior software engineer at WSP. He's worked in the industry for 7 years and has spent more time than he would like to admit debugging Django and Python code. Luke was also, a long time ago, an Australian representative gymnast competing at the Commonwealth Games and World Championships. Please welcome Luke.
All right. Test, is this thing on? Yep, cool. Today we're talking about Django on AWS for chump change. So really the inspiration of this talk is Heroku, which when I first started out writing Python code was a real forerunner in making it able to just deploy Python code out there and get something out for really, really cheap. I think things have kind of changed over the years with Heroku, but the eventual goal is to kind of somewhat build our own Heroku in AWS. If you want to play along, all the links that I have within this talk are over on my website in the blog. You can also skip ahead to see the end of this, so you don't have to hear me ramble on for half an hour. My name is Luke Wiwatowski. Well done to anybody who knows to actually pronounce that last name, but that's okay. Yeah, I'm a senior software engineer for WSP, and in my former life, I was Australian level representative gymnast. If you want to catch me on any of the socials, Luke Wiwa is my handle. You know, find me wherever. So first off, let's talk about AWS. If you're going to build something on AWS, specifically with Django and Python, here's an enterprise grade stack. Enterprise in inverted commas, because this is about how much I could fit on the page. Ignore all the stupid names and stuff. I didn't really have time to draw pretty pictures about how you would do it, but this is kind of an auto-generated thing from AWS to show you the kind of stack we're talking about here. So that's pretty complicated. It's pretty annoying. There is another way to represent this, and that is in code. So here's the same thing. Don't be too worried if you can't fully understand what's going on here, but essentially, all that stuff that we had over there is now written down in some nice, easy-to-read, inverted commas, Python code. Very logical, structured, bang, 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 down the page. So what we're going to do here is we're going to play a game. We're going to build a Django app, but we're not going to scale it up to enterprise. We're going to scale it down. Imagine you've got this app, you've built it up, and you want to share it with your friends and family, maybe just one other person, your partner. You don't want the world to see it. You don't care about scale. You want to scale down. How do you do that in an AWS context where everything is pushing you to scale up? So I've built a Django app for my family. I want to host it somewhere, and I don't want to maintain it. I don't want any pets. I don't want to bother with a VPS or anything. I want something that I can push a button and it'll spin up, and push a button and it'll spin down, and it'll largely self-correct. The rules, AWS exclusively. There are plenty of services out there you can use, but AWS is the gorilla in the room, and it's a good learning exercise. We're going to use infrastructure as code because we're in a Python conference. We're going to write some Python to spin up all these services. In this case, we're going to use the AWS CDK, which is the Cloud Development Kit, I believe. There will be a lot of three-letter acronyms in this talk, so apologies if I get ahead of myself and I don't explain them all. Another one, we're not going to use any stateful services like EC2. There's been plenty of other talks in Pycon over the years about how you can make a EC2 instance really cheap, essentially run it as a VPS. That's not this talk. I don't want to run a VPS. I just want to spit the code at AWS and have it do it all for me. And finally, we're going to use Django because Django is an excellent web framework, and we love to use it, and we want to deploy it everywhere we can. So I'm going to have a little bit of audience participation here, so just yell at me. What's expensive in AWS? Come on, tell me. Databases, yes. Queues, storage. Yeah. Almost everything is a good answer, yes. There are a couple of specific ones that we're going to talk about in terms of Django specifically, and that is, yes, relational databases, the services, RDS, which is, the relational database service. Load balancers can get very expensive as well, especially if you're just spinning one up singularly. Suddenly, if you're a poor student in a dorm room and you're paying $20 a month for just a load balancer, that's a bit pricey. NAT gateways, they can bite you in the butt. And AWS is very sneaky in that it will spin these up for you without you explicitly knowing. AWS is very helpful in that scenario. Also, like WAF, Web Application Framework, can be expensive too. So we're actually not going to talk about the WAF. We're just going to let things hit our servers. What's cheap? What's cheap? Lambda. Lambda, yes. Lambda is very cheap, scales to 0. Anything else? Spot instances, yes, very good. Anything else? S3, yes, the canonical storage service in AWS. CloudFront, also very cheap as well. We probably won't cover this today, but really good to front anything you do on AWS with a CloudFront instance as well. But yeah, I think you got them all. And we're going to transfer over to using these. So as I said before, we're going to use the AWS CDK. There's plenty of tools like this under the infrastructure as code umbrella. What are they called? Terraform, OpenTofu, Pulumi? I think there are a couple of others. On this occasion, we're just going to use the CDK, 1, because it's native to AWS, and 2, because it's cheap. It's very good. I have links in my blog post to just the general Hello World starter. On this occasion, we're using Python. On a slight aside, if you do happen to use other languages, I would say that TypeScript ends up being the best in terms of support for CDK and ergonomics. Python's still pretty good, but TypeScript is what it's actually written in under the hood, and that ends up seeing the earliest support for newer features and stuff. What CDK actually is just a wrapper around CloudFormation, which is AWS's way to spin up all these services through like a template. CloudFormation is like YAML blobs and JSON blobs all the way down, and it sucks. So we're going to use Python instead. So let's begin. From our enterprise-grade stack, we're going to do some quick, easy savings that should have pretty much 0 practical effects on our application. So first off, we're going to remove the load balancers. And before I keep going, I will say what we're doing here is we're going for the cheap services that scale to 0. There is always an inflection point where if you end up getting a lot of load, it's often better to go with a load balancer than the alternative because you get savings because of the load. So this is how we would define a load balancer in CDK. Really simple. We've got our load balancer connected to our VPC. It's going to be internet-facing. Really nice, easy language to understand. We add a listener to port 80 or whatever port you want, 443, I guess we should say here. And then we add our Django container, port 8000, which, Django by default kind of serves on that port. And you're good to go. But this is expensive. You spin one of these up and you're spending $20, $30 a month just on the load balancer alone, and that's not including any of the requests or services. So there is an alternative. Anyone want to guess what it is? API gateway, I've heard. Very good. Gold star to the person in the back. Here we're going to do it in an ECS, Elastic Container Service context. So everything we're doing here is we're running Django in a container. That makes it easy to kind of switch between different services. We're going to use ECS because, one, it's cheap. Two, it's native to AWS and makes it really easy to spin up stuff in the CDK. EKS is a different nightmare. All deployments are nightmares in some way, but we're not going to use the EKS because it's expensive. So yeah, here we go. In our ECS cluster, we simply enable Cloud Map, simply because everything we do here is actually going to be adding code and doing things in a more difficult sense. Cloud Map is a way to add a network within your ECS cluster. Don't care about the implementation details, but we add it to our cluster. We add a service endpoint so that our container can read out to the VPC link. So we're inside a VPC. Everything happens within a VPC, which is a virtual private cloud in AWS. And we attach it via an integration to an API gateway. All of this, trying to do it in the console, or trying to do it through CloudFormation, or trying to do it through any other method is like really, really verbose and annoying. But here we have these lovely integrations, specifically default _ integration equals HTTP service discovery integration. Bang, you're off to the races. You're out to the world. What we are going to ignore in all this exercise is DNS. That's a completely different problem, which you can do in several different ways, but we're out to the internet. Great. And we've saved a few dollars. Next, we're going to use some Spot instances. Somebody over here mentioned Spot instances. So here we're going to use Fargate services because I don't want to manage the cluster in any meaningful sense. AWS will spin up all the services underneath for me. So here we're going to make sure that we have exactly one container running because we don't need more. We don't need scale. We don't care if it goes down for a few minutes or whatever. And we're going to set the capacity providers to Spot. Spot instances are what AWS kind of gives you is like their leftover CPU cycles from other instances that people aren't using. Generally speaking, it's a pretty reliable service, but AWS will caveat with that it could go down from time to time, and your service just needs to be able to spin up and down and know that it might get taken down. Generally speaking, though, if you're just spinning up one Spot instance, you're generally okay, especially with our application, which is just for my friends and family. If they notice that it's down, hit a refresh, it'll probably be up again. All right, those are the easy wins. Now we're going to start doing some slightly more risky stuff with some trade-offs, but you know, we want to save money at the end of the day. We're a poor college student in our dorm room, and we want to save a few bucks. So we're going to remove NAT gateways. NAT gateways. What is a NAT gateway? Someone tell me, because I don't know. I mean, I know it does some sort of translation and allows you to speak out to the public internet. These are sneaky things that AWS will spin up for you. If you just spin up a virtual private cloud with no parameters whatsoever, it will by default give you 3 subnets, a public, a private, and private with NAT. Generally speaking, if you follow all the guides in AWS, it'll push you to running your application within the private with NAT, and you run your database service, for instance, in the private subnet, but basically giving you a little bit of protection so that not everything is out to the open internet. But here we're going to go straight out to the open internet. Set NAT gateways to 0. We might have 2 subnets. We'll have a public one and a private isolated one, but we're definitely not going to have one with a NAT because they are quite pricey, and you pay not just for the NAT instance, but you pay for the traffic that goes through it as well. All right, big one. We're going to remove RDS. We're going to remove the Postgres service, the managed service, because you know what? Let's just do it ourselves. It's not that hard, right? Who who needs data reliability anyway? So this is how you would define it in CDK. Pretty simple. You make your database instance, and then you attach it to your VPC, set your engine and which subnet it goes in. This would be quite a bit of a faff to do if you're doing it through ClickOps or through CloudFormation or whatever. But here it's super easy. But we don't want any of that. We want it complicated. So here's a really simple way to spin up your own Postgres service using a Postgres container, chucking it in EC2, Actually, I'm surprised that actually fits on the slide. Let's dumb it down a bit. Okay. So all you do is add your EFS file system, elastic file system, add the file system to ECS volume, add the volume to ECS task, add the container to the task, mount the volume to the container, add the task to the service, allow service to connect to the EFS, map the container service into the cloud namespace, and you're done. Simple. Let's compress it down a bit. Let's talk it through slightly. So what we're going to do, first, we need a persistent file system. Everything in ECS, in the Elastic Container Service generally, is like stateless. And you need to do special things to give some state. And of course, AWS has a service, or in many cases, many services that will do this for you. On this occasion, we're going to use the Elastic File System, which allows you to map basically a volume to a container. If you've worked in the container world, if you've used Docker Compose, Docker, you might be familiar with mounting persistent volumes to containers. That's just essentially what we're doing here. But of course, because it's AWS, we have to do it in a very verbose fashion. So we've got our file system. We create our persistent file system. We attach it to an ECS volume. Then we attach it to the task definition, which is basically the definition of how we're going to run our container. The task becomes a service. You attach the volume to the service, and then you give permission to the service to actually talk with the volume itself. Remember this. Just remember the pattern, because it might pop up again soon. So there we go. We've got our own Postgres container running in ECS. We're not paying for RDS anymore. Big savings. Because I think the lowest RDS instance is still quite expensive just to spin it up. I know there are like Aurora services as well, which are also very expensive. But anyway, if you're doing a relational database service in AWS, it's expensive as hell. But what we could also do is not use Postgres at all. We could use SQLite, which, you know, on a big project, I wouldn't recommend. But on a small project like this, we're only going to have like a couple of dozen users at most. SQLite's pretty good. Django has excellent support for SQLite. SQLite itself, yeah, you can get into trouble using it raw, but Django gives you a lot of protections over it, and generally, in a small app, it's not too bad. And it simplifies the stack. It gets rid of network calls. How are we going to do this? Does this look familiar? We add an EFS file system. We add the file system to ECS volume. We add the volume to the task. We add the container to the task. We mount the volume. We allow the service to connect to EFS, and we map the container service into the cloud map namespace. Simple and cheap. We've just saved ourselves a bunch of money on another ECS service. Some technical details here about where you mount the actual container. Here we're just doing it to the temp path. You can do whatever you want. But the basic idea is there. And now we've kind of hit our limit of things we can do with a Django app without actually doing anything to the Django app. We've done a bunch of stuff with services around. Let's cut to the bone. Let's get wild. Let's use Lambda. How do you run a Django service in a Lambda service? On this occasion, I would very much suggest you use a Docker image. AWS has like Python runtimes, and they all suck. They're all really annoying to work with, and it's just really hard to recreate what AWS is doing under the hood with their Python runtimes. So in general, I suggest if you're going to do Python in Lambda, just chuck it in a Docker function and then throw it over. So this is how you do it. We use that same file system that we used for SQLite. You got to do some magic, which is well documented out in the AWS docs about how you mount your volume to a Lambda function. We attach our Docker image, and then we do an API gateway integration. Once again, this will be all complicated in ClickOps, but it's actually quite simple when you write it out in the code. A few problems, though. This will spin you up a NAT gateway. Very, very sneaky. And Lambdas don't work out of the box with a Django application like this. So we got to do a little bit of tweaking now within the actual application code to make it work. Turns out AWS has built something to make that really, really easy. So there are a bunch of libraries that will do this translation of what a Lambda response looks like into a HTTP response. I think Mangum is one of them that's out there. There's a bunch of others. But what I really don't want to do, I don't want to mess with application code if I don't have to. So we're going to use the advantage of the Docker image, and we're going to use this thing called AWS Lambda Adapter, the Lambda Web Adapter. And basically what it does, you just do this one line of code in from public ECR into this particular directory in your container. And then when you run it in Lambda, you'll just get a HTTP request. You can run gunicorn, uvicorn, whatever, uwizgy, whatever works for you, and it should just be plug and play. And the advantage of this is when you run it locally as well, it just ignores that. So you can just run Python manage run server for your local, and then you run your gunicorn in production, and you should be good to go. Links there, links also in my blog post about it. Check it out, it's pretty cool. I haven't checked it recently, but it's in the AWS Labs GitHub organization. So it's still experimental, but plenty of examples, not just for Python, but for a bunch of different languages. Okay, there we go. Can we go deeper? What can we do here? What's cheaper than EFS? S3. S3, the cheapest file system. File system, it's not really a file system, but let's make it a file system. So I built this little library here. I will admit, it's not original. There was something like this in Zappa, which was a library to help you deploy Django applications to AWS Lambda. Essentially what it does is it just downloads a file from S3 locally, you do all your changes, and then re-uploads it. So really safe, your data's safe. S3 is a really, really robust object storage. Don't do this for work. Once again, as I say at the start, not employer approved. We do not do this in production at all, so don't try. So how do you do this? Okay, we create an S3 bucket in CDK. Super simple. It's the canonical example. Create an S3 bucket, whatever library you're using, super easy. And then we just map it to our Lambda function. Here, I'm using an environment variable. Do it however you want. Specifically, you do need to make sure that you map it to the /tmp file when you're working in Docker, when you're working in Lambda, because that's the only writable directory. And then you've got to do a slight bit of Django settings. So install Django SQLite object storage, make sure it knows the bucket name, and you should be good to go. And given all this, now we have our stack, or that big initial stack has whittled down to something like this, which is pretty small and gives you a pretty good amount of functionality for a Django app that you're going to share amongst people. You lose a few things. Initial response, cold starts, pretty slow. But you know what? That's something you can live with. You can do this a bunch of times. If nobody hits it at all, you pay nothing, which is absolutely great. All these services scale to 0. There are some opportunities that I haven't covered here. So you could explore scheduling of spinning stuff up and down. AWS has Event Bridge Scheduler, I think is the name, which is really robust, and you can do all sorts of crazy things. Also with CDK, you can do crazy things with lambdas for internal DevOps-y type code. It's really, really useful for that. I used it as a bit of a DNS resolver for a little bit of time there. I decided not to use a load balancer, and I just mapped whatever the public IP address of the container was to the DNS, which is not great. I wouldn't do that in real life. You know, it's not happening anymore. You could perhaps use Lambda as a proxy to negate the need for NAT gateways. There is a weird way you could do that in some certain scenarios where you're only hitting external, like a specific external API. And you can also use, I don't know if I'm going to pronounce this wrong, FCK NAT to reduce NAT costs as well. There's like a CDK tutorial on how you can just easily add it so that your NAT costs go down. But that's really where we're at. We've run out of time, and we've gotten to the point where you've built your app, you've shared it with your friends, you haven't looked at it a while, and you finally log into your AWS account, you look at the logs and you see nobody's hitting it. And you realize, man, I haven't used that app in a long while. Why is it even there anymore? Let's get rid of it. And it's really, really easy through CDK to just get rid of all those resources as well. Everybody's got that story of, oh, I've got that one cost that keeps coming up in my AWS bill. It's like 30 cents. I have an S3 bucket somewhere and I don't know where. CDK and CloudFormation gives you a lot more overview of all your resources, and this is super, super useful. Not just for when the project's done, but for when you're spinning up and you're just noodling around and figuring out what to do and how things fit together. Thus ends my talk. Are there any... I think we have 1 minute for questions. Any questions from the floor?
Oh, we got one up the back, and then I'll come back for here. I'll come to you.
Thanks for the talk. I was wondering how much are you paying for your personal app that you deployed using that cheap method?
Well, the brilliant thing is that Lambda has a whole bunch of stuff in the free tier, and I'm paying 0. Well, that's unfair. I'm paying a couple cents for S3 costs, I think. But I run a few stupid little apps through this method, and largely, I don't know, the bill comes in and it's like a couple of cents. So, caveat though, I will say, if your app gets popular, all this goes out the window. All of it. You will suffer the pain of those services. As I said before, there's that inflection point. And Lambda's cheap until it's not. If you start to get really popular, that's when you have to start thinking about switching over to something like ECS and load balancers and stuff where you get the cost of volume actually drives those prices down, if that makes sense. Sorry, one more question was there? Yes.
Would you suggest using like event watchers for spooling up the ECS instance via Route 53's logs? It's really cheeky.
As I mentioned before, there are plenty of opportunities here with schedulers and events and stuff, And because CDK makes it super easy to spin up little utility Lambda functions, yes, there's probably an opportunity where you could spin everything down to 0, and then when you get that request after some timeout, let's say someone, you spin everything down and someone finally hits it the next day, you hold on to the request, you spin everything up, and then do the, do the request. Very much like what Heroku used to do on its free tier. I don't know if I'm talking to the right crowd here, but Heroku used to spin down to 0 if it had no traffic after, I don't know, X amount of hours. And that was how it kind of made its free tier viable. You could possibly build something like that too. That's definitely an option, especially if Lambda is not good for you. Lambda kind of sucks when it comes to, longer running things and things where you want a file system and yada, 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 so on and so forth. But this is AWS. The world is the horizon opens out in front of you, and you can do a lot of stupid things. That's time, isn't it? Thank you.
Alrighty then. Thank you, Luke.